Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're gonna explain the stress, average normal stress, which is lecture number 12. إيش the definition of stress? Considering a small force acting on an occasional area, we get the stress. أو stress يعني لو نتذكر من تعريفه في الفيزيكس اللي هو pressure. It can be demonstrated as a force acting on area. والunit بتكون Newton per meter, or Newton per meter is also called Pascal. طبعا in this lesson or in this course we're gonna consider the materials that are يعني uniform, فبيكون الستريس جاي يعني متساوي في كل ال areas حقت هذا الماتيريال. Okay, so when normal means the axis perpendicular to the cross-sectional is called the orientation of the area. When normal stress is always acts along the orientation حق هذا اللاين. فالnormal stress إذا كان عندي هذا البوكس، فالnormal stress هو الشيء perpendicular to the area دائما. The axis tangential to the cross-sectional are called direction lines اللي هما ال Z وال Y, التاو ZX والتاو ZY. We call this a shear stress and always acts along the direction of the line. يعني يجي دايما tangent أو مماس للسيرفس، يعني بهذا الشكل يكون عندنا اسمه shear stress. أما اللي يجي perpendicular فهو الnormal stress. فالحين تعرفنا على نوعين من السترس، الشير والنورمال. الشير يجي tangent، أما النورمال يجي perpendicular. So this one we call it sigma and it represents the normal stress, and this one is called tau and represents a shear stress. تمام، هذه اليونت اوف ستريس زي ما قلنا ان نيوتن بير متر تعطيني باسكال، أو متر سكوير عفوا تعطيني باسكال. لكن إذا كان كيلو نيوتن فبيكون بعد كيلو باسكال. إذا كان نيوتن بير مليمتر هنا يكون عندي الميجا باسكال. طبعا كيف تتذكرونها؟ أول شيء عندنا هنا نيوتن over المليمتر سكوير. كيف أتذكر إنها ميجا باسكال or 10 to the power 6 Pascal, which is mega. Just remember if you are gonna convert this one، أول شيء المليمتر سكوير، المليمتر الواحد corresponds to كم متر؟ 10 to the power minus 3 متر، صح؟ يعني إذا أنا لازم أسوي conversion units per 1 مليمتر، تمام، ولازم أسوي له سكوير فبيصير 10 to the power minus 6، ودامها في الدينومينيتر بتطلع فوق وتصير 10 to the power 6 باسكال. أوكي، الحين أول شيء بنبدأ في الأفريج نورمال ستريس على اللودد بار. So let's consider a bar subjected to an axial load shown in the following figure. طبعا normal stress يجي على شكلين، يجي يا tension أو يجي compression. So we represent the average normal stress with sigma and the internal resultant normal force acting through the centroid of the cross-section as P, and the cross-section we represent it by A. cross-section يعني هي هذه، إذا جيت أنا سويت يعني قصيتها I get this cross-section and it's a circle. زي ما قلنا إنه we will assume it's deforms uniformly under load or subjected to axial load acting through the centroid of the cross-section area. تمام. For a bar having different axial forces at different locations along its length, الماكسيمum average normal stress can be determined. طبعا we will not plot this diagram, but we will find where is the largest normal stress acting, and this largest normal stress is gonna correspond to the largest sigma. I mean, where is the largest force acting, and it will represent for us the largest sigma. So in this example, bar width is 35 and the thickness is 10. So إذا أنا جيت I took a cut over here, I'm gonna get this rectangle that has a thickness of 10 and width of 35. That's the meaning of it. Determine the average normal stress in bar was subjected to the loading shown. Determine the maximum. So how can we find the maximum average normal stress? We need to find where is the largest normal force. So I'm gonna start by making a cut, exactly like how we used to do في internal forces. So if I'm gonna make a cut over here, I'm gonna get this section. طبعا حنا كيف we solve these questions, we make a cut and we draw a free body diagram for each section. So here it is 12 kilonewton, and this one is NAB is equal to 12 kilonewton. Okay, let me make another section over here. خلاص خلصنا من هذه السكشن. So I will take all of this, or you can take all of this, it's gonna be the same يعني, it does not matter. So here I will have 12 هذه 12 plus 9 plus 9 لأن كلهم في نفس الجهة ف it's 30. وهذه NBC is equal to 30. Okay, if I make a cut over here, I will take this section بكون 30 minus 8, which is 22. And if I make a cut over here, بعد هذه بتكون 22. So where is my maximum force? It's this one, 30. So now I know that the equation of sigma is the normal over the area. Now what is the normal here? It's 30. This one is max, so this one must be also max. Over the area, which is 35 times 10. Millimeter, so it will be millimeter square. And this one is kilonewton, so multiply it by 10 to the power 3 in order to convert it to Newton. So my largest sigma is 85.7 megapascal. This one here is the same thing. He wants us to determine the distance of the centroid, يعني find y. How to find it? You need to first of all find the area of this and then the area of that and the y bar, and then you can determine the centroid. However, here this is not the issue of this lesson, so I'll just focus on finding the average normal stress. What is the average normal stress? We said it is the pressure over the area. Now my area is all of this. If I take the cut over here, يعني if I take the cut, it will be something like that. It looks like this. هذه الاريا حقتي. هنا it is 250. This one is 20, and all of that is a 300, and this one is also 20. So I can think of it as composite shape. الاريا أول واحدة بتكون 250 times 20 plus 20 في 300. and the pressure on it is 80. The force on it is 30 times 10 to the power 3. So we got it as 7.27 megapascal. Okay, now let's see this question. You're going to determine the largest value of P if the average normal stress in the material is limited to 120 psi. Okay, so the largest sigma is 120. So we need to determine the largest value of P. So we said that the largest sigma corresponds to largest force. Here I need to find the area in order to find the P max, because P max is equal to the sigma في area. So we need now to find the area. This one here can be sectioned into, I can take all of that as one area and all of that as another area, and here we will be left by this. Okay, so I will call this one 1, this one is 2, this one is 3, this one is 4, and this one is 5. So 1 is equal to 2, so I'm just gonna multiply their areas by 2, and they are 1 times هذا كله. And it's 14 times 1. 28. هذه area of 1 and 2. And now we need to calculate this one. 4 times 2, 4 times 2, 4 times 2. So area 3 is equal to 4 is equal to 5. واللي هي 4 في 2. بضربهم في 3 عشانهم 3. هذه summation of the area. Okay. Now sigma is 120. So قلنا إن P بيكون 120 times 52. So هذا largest P. Okay, نيجي لهذا السؤال. يقول لنا 80 kilogram lamp is supported by 2 rods AB اللي هو هذا and BC as shown. AB عندها diameter is equal to 10 millimeter and BC diameter is 8 millimeter. Determine the average normal stress in each rod. So قلنا average normal is equal to the force, or you want to call it P, you want to call it F, over an area. So in order to determine this one, we must find the area and we must find the forces. تمام. Now let's start by drawing a free body diagram. أول شيء 80 kilogram, we must convert it into force, which is 80 times 9.81. ضربتها بالاcceleration due to gravity in order to find its weight, because we are given the mass. So this will be 784.8 newtons. Kilogram which is like mass times acceleration. You remember this. Okay. So بيكون عندي هذا الأوبجكت or خلاص عندي هذه النقطة and here I have this one is 60 and I will call it FAB and this one is FBC and here we have 5, this one is a 3 and this one is 4 and here we have الفورس أو الويت اللي طلعناه 784.8 newtons. Now we will need to what? We will need to determine the forces. So let's start by summing the forces. Summation of forces in the x direction. It's going to be minus FAB the cosine 60 plus FBC times 4/5. Okay, so I will rewrite this one. So FAB is equal to 1.6 FBC. Keep this one aside. Now we will go to summation of forces in the y direction. It's going to be FBC the 3/5 plus FAB sine 60 minus 784.8. Now go back and we need to take here a common factor in order to solve for one of them. So I will rewrite FAB as this. So here, this one is going to be FBC 3/5 نفسها. And here FAB, instead of writing it like this, I will write it as 1.6 FBC في sine 60 equal to 784.8. وديتها للجهة الثانية. Now, taking FBC as a common factor, we're going to be left with 3/5 plus 1.6 times sine 60. 1.98 So FBC is equal to 395.24 newtons and its tension. And FAB will be 1.6 of FBC, which is this one. So FAB is equal to 632.38 Newton بعد it is tension. Now I need to find the area. Area of AB is equal to pi/4 10 squared. Well, area of BC will be pi/4 and the diameter is 8. So now the only thing left is to find the normal in each one. So the normal in AB will be ناخذ الفورس which is 632.38 over الarea which is 25 pi. This one will be 8.05 megapascal because this one is in Newton per millimeter. And this one in BC will be 395 24 over 16 pi. You get this one as 7.86 megapascal. Okay, so let's see this question. The uniform beam is supported by two rods AB and CD. Have a cross-sectional area of 10 and 15. So هذه عندها cross-section of 10 and this one has a cross-sectional area of 15. وهذه distance قال لنا 1 meter. Determine the average normal في AB في CD. First, let's start by drawing the free body diagram. Okay. We will assume that these two are two force member. هذه FAB and this one is FCD. And distributed loading إذا هذه كانت 1 for this one is 3. So I'm going to say 3 by 3 and this is equal to 9. And I'm going to put it exactly in the middle. So if this one is a 3, in the middle is going to be 1.5. So 1.5. Going to put the distributed, the force, kilo Newton. So now we need to find the summation of forces in the y. It's going to be FAB plus FCD minus 9. So FAB plus FCD is equal to 9. Now we can find the summation. This one is 4, so 4 minus 1.5. هذا كله is 2.5. Now we can find summation of moment around this point, which is A. So it's going to be minus 9 plus FCD times 4. So FCD is equal to 5.625 newtons or kilo newtons, and FAB is just 9 minus this answer from this equation, 3.375 kilo newtons. Now we gotta find the sigma in AB. It's this force, 3.375 times 10 to the power 3 in order to convert it into newtons, and area is 10. (337.5 megapascal), and sigma in CD is 5.62 over the area, which is 15. So it's 374.67 megapascal. And here we reached the end of the lecture. We just have one extra question. So let's have a look at it. The built-up shaft consists of a pipe AB and a solid rod, this one, CB, هذه. The pipe has an inner diameter of 20 and the outer diameter of 28. And the rod has diameter of 12 millimeter. Determine the average normal stress at point D and E and represent the stress on volume element located at each of these points. Okay, so we need أول شيء to find الforce, الnormal force على هذه الpoints. So at point D, if I make a cut, الnormal بيكون this one here. This one is point D, and I have the normal is equal to 4 kilonewton compression. And if I make a cut at E, it will be I can take it من هنا. So it's just 8 kilonewtons. هذه يعني عندنا 8 kilonewtons, and here the normal, its tension also equal to 8 kilonewtons. So NE is equal to 8 kilonewtons tension. Now I need to find the average normal stress at D and at E. So it will be the area, the average normal stress at D is ND over area. Now what is the area of D? Here we see that if we make a cross section at this pipe, it consists of an inner radius and outer radius. Here it's empty عشان الرod enters هذا this pipe. So we need to find this area. How can we find it? It's gonna be the inner radius, or the circle of the inner radius minus the circle of the outer radius. So I'm gonna calculate the outer. Okay, minus the inner. What is the outer? It's gonna be pi r squared. And it has inner diameter. Outer is 28, so half of it, or just multiplied by pi over 4, 28 all squared, minus pi over 4, and the inner diameter is 20. We get the area as 301.6 millimeter square. So the normal is gonna be 4 kilonewtons over 301.6. Which is 13.26 megapascal. Now for this one, the area of the rod, it's a 12, so area is equal to pi over 4, 12 squared. And that is 36 pi. So 8 kilonewton divided by 36 pi in order to get the average. And it's 70.73. Now we reached to the end of this lecture.